This video will cover matrices, determinants, and inverses. Specifically, we will learn how to evaluate the determinants of 2x2 matrices and use inverse matrices to solve equations. Our first topic is evaluating determinants of 2x2 matrices. When two matrices, A and B, multiply to yield the identity matrix I, they are considered inverses. The 2x2 identity matrix is shown here. To prove that two matrices are inverses, you only need to show that AB equals I, or BA equals I. Similarly, to show that A inverse is the inverse of A, you only need to show one of the two equations, AA inverse equals I, or A inverse A equals I. Let's work through an example. Show that matrix B is the multiplicative inverse of matrix A. We are given the values for matrix A and matrix B. To show that B is the inverse of A, we will multiply A and B. The resulting matrix for AB is shown here. When we multiply matrix A by matrix B, the result is the identity matrix, I. Since A, B equals I, B is the inverse of A, and A is the inverse of B. The product AB resulted in the identity matrix. To verify, we could also multiply BA, and the result should be the same, the identity matrix I. When we multiply B by A, the result is also the identity matrix I. Since both AB and B, A equal I, A and B are confirmed inverses. Let's try a second example. Show that the given matrices A and B are multiplicative inverses. We can show this by calculating BA. The product BA results in the identity matrix I. Therefore, B is the inverse of A and A is the inverse of B. The determinant is used to determine if an inverse of a matrix exists. If the determinant is not equal to 0, an inverse exists. If the determinant equals 0, no inverse exists. To calculate a determinant for a 2x2 matrix A, represented as A, B, C, D, we use the notation det A. Note the straight lines used in the determinant notation rather than brackets. To find the determinant, we multiply the elements along the diagonals. The equation to find the determinant is A times D minus B times C. This is the difference between the products of the elements on the main diagonal and the elements on the other diagonal. Here is example 1. We are asked to evaluate the determinant of the given matrix. We can represent the determinant of the matrix using straight lines. The elements along the main diagonal are 7 and minus 9, and the other diagonal elements are 8 and minus 5. We illustrate the diagonals with arrows. Following the formula, we calculate the determinant as 7 times minus 9 minus 8 times minus 5. This equals minus 63 minus minus 40, which simplifies to minus 63 plus 40, resulting in minus 23. Since the determinant is minus 23 and not 0, the inverse of this matrix exists. Next, let's try example 2. We will evaluate the determinant of the given matrix. We represent the determinant using straight lines. The calculation is 4 times 2 minus 2 times 4, which is 8 minus 8, resulting in a determinant of 0. Since the determinant is 0, there is no inverse for this matrix. How do you know if a matrix has an inverse, and how do you find that inverse? The determinant helps you know if an inverse exists. The equations for finding an inverse matrix are provided on page 201 of your textbook. An inverse exists if the determinant is not equal to 0. Let's work through example 1. Determine whether the matrix M has an inverse. If an inverse exists, find it. Step 1. Find the determinant of matrix M. The determinant is found by calculating minus 1 times 5 minus minus 3 times 1, which simplifies to minus 5 plus 3, or minus 2. Since the determinant of M is minus 2, which is not 0, the inverse of M exists. Now we proceed to step 2. Rewrite the matrix in its inverse form. To rewrite the matrix in its inverse form, we need to change the signs of the elements on the other diagonal. The minus 3 becomes 3, and the 1 becomes minus 1. The updated matrix now has the elements minus 1, 3, minus 1, and 5. Next, we change the positions of the elements on the main diagonal. We swap minus 1 and 5. The matrix now shows 5, 3, minus 1, minus 1. This matrix is used in the final step to find the inverse. Step 3. Use the equation to find the inverse. The formula is 1 divided by the determinant multiplied by the modified matrix. We use the modified matrix from the previous step. We substitute the determinant value of -2 into the inverse formula. We multiply -1/2 by each element in the modified matrix: 5, 3, -1, and -1. This multiplication results in the inverse matrix, M inverse, with elements -5/2, -3/2, 1/2, and 1/2. Now, let's look at example 2. Determine whether the matrix N has an inverse. If an inverse exists, find it. Step 1. Find the determinant of matrix N. We calculate 2 times 10 minus 5 times 4. This equals 20 minus 20, resulting in a determinant of 0.